let's just get started. I hope you guys can hear me. Okay. Hello? Hello. Good evening, everyone. Can you hear me? Oh,
Yes, we can hear you. I can
okay,
hear you.
Dr.
I
Kevin.
don't know about the others.
Okay. All right. Okay. Good evening, everyone. Sorry. Apologies and please, it will not happen again. Even though something happened, crisis, even though something is flying, bullet is flying on top of my head, I'll find a way to make sure I will not miss classes again. Sorry about that. I really had that yesterday. I was really, really uncomfortable. Okay, so uh, let me go straight to. I'll be sharing my screenshot key to find a way and finish the comprehension. So in the next class, that will be tomorrow. We'll just start the project. So let me share my screen. I don't know if you can see my screen. Yes, you can. So if we look at this, let's see something here. I think we stopped at nested comprehension. Stopped at nested. Okay, we're about entering nested comprehension. And what happened? I saw some persons in the meeting before now. Okay, we have nested comprehensions, and when you made mention of nested comprehension, it's just like more of like something inside something when it comes to a loop inside a loop, a comprehension inside a comprehension. So that means anything that we've been doing so far, we'll just do, maybe we'll be doing one line, maybe we'll be just doing a particular comprehension. We're also going to do another comprehension inside this particular one. So the very first example we want to look at is we have two lists and we want to create a new list of tuples. Okay, so we have two lists. You can see the two lists here. The tuples, the tuple elements will be the pairs of the items from this word list. So this particular uh, tuple element you are going to form is going to be from this particular list, and you can see the expected outcome. We want it to look like this. That means A comes into one, B comes into two, and also you can see here there's actually something that is actually different here when it comes to A and 3 coming out here. So let's see how we can go through this using the classical way, of doing things. So the first thing we're going to do is we have gotten numbers and letters already, and you can see here, first of all, the normal classical way of doing things is result is equals to an empty list. So we're going to append those things inside the list itself, and let's see what we can come up with. So first of all, we go to loop it. So for letter in letters, remember the outcome, we want to make it like this. So we first of all we have to put it in a loop, and each of those elements inside the loop, there's something we want to do with it. So for letter representing a single element in letters, remember the letters here was given here. So what do we do? uh, what do we do now? Say for letter in letters, for number in numbers. Those are two things inside what you call inside this particular for loop. There are two for loops here. The very first one is for the letters. The other one is now saying, okay, inside this particular letter that you are getting, I also want to get it. I also want to attach number to it as you are looping this letter. As this letter is going through a loop, is coming out as his own elements letter, and also numbers too that you have already here is also coming out as its own numbers as well. So by the time you do this, you append this into a list. So you append this, you create a tuple. Remember, a tuple is always in a normal bracket. You put a normal bracket to it. That's creating a new variable. And if you can see this bracket here, tuple kind of bracket, putting this letter and numbers together, putting this letter and numbers together. And by the time you run this, you print this out result, it's going to give you because this result here is an empty list. And by the time you append it, this particular tuple to this particular this result that is an empty list is going to give you a list of tuples. A list of tuples is going to give you a list of tuples. Let me try and run this. Seems I'm seeing some things here. Let me try and run this. Let me connect this so that if you have any issues, you can actually fix it up here. Let me connect it and run it directly. So it's connected. So first of all, let me run this. Let me run this particular one. Okay. So now let's see what you have here. Let's see what we have here. Let me run this. So you can see here, we have the outcome here is A, 1, A, 2, A, 3, B, 1, B, 2, B, 3. It means that if you can look at this particular interpretation of code, we can look at this interpretation of code right now. It's trying to tell you the first one started with letters. We can see it means that each of these letter, as it is looping, it is taking each of the numbers. It is taking each of the numbers. Please, if you can look at it very well, comparing to the number of times we said that when we want to unpack, when a particular thing is unpacking, if it's not equals to the same particular thing on the right-hand side, it's not going to work. But if you look at this particular loop very well in a Python kind of way, you can see that this letter that is looping, the letter as it is looping, like for example, the first one could be what could be A, that particular A is looping, it is also taking in the numbers in which it's also looping. So A can loop the first time and comes in and do what? Taking what? One, that is one of the numbers here, and loops again. A again comes out again because of the number of times, because of this particular for number in numbers is going to be what? 3 times for each of this particular letter because of this. But if this numbers was if this number was 4 here, it could have this particular numbers could have also looped it could have gone 4 times. I don't know if you remember when we were dancing there was something we were doing back then for a nested kind of loops. That time we were trying to kind of say, okay, if this one is coming, this one is for the rows, this one is for the column. You see the same concept here. So each of the letters, as the letter is coming out, is taking in the number in this particular for loop. So as far as this particular number of this line 6 must loop 4 times, it means that this number 5 will also go through that particular condition 4 times just to make sure that it gets each of the value. That's why A is coming out 3 times because A has to go for 1, A has to go for 2, A has to go for 3. The same thing with B. B has to come out for 1, has to come out for 2, and has to come out for 3. If this particular place was 4, it could have gone out 4 times. A could have had A1, A2, A3, A4, A3, A4, just like that. That's why this particular concept is trying to tell you. You can see there was a ... continue. That means you can also continue as well. So now we have gotten to this particular step of classical loop. Let's look at the comprehension way of doing it. Let's see how we can do it in a comprehension kind of way. So how do we make that possible? We want it to be in a list of tuples. So we can see, if you can look at this concept, that's the very first thing you look at in nested, whenever you're trying to get a nested kind of situation. So you can see I did results underscore comprehension, that is com, equals to, if you look at the square bracket I put here, you can see the square bracket. I need it to be a list of tuples. So you can see I started with a square bracket, and inside this particular square bracket, I added what? I added letter and number. I added letter and number. This letter and number is going to be inside what? A particular word, is going to be for the for loop, and this particular for loop is just the same thing here for letter in letters, for number in number. This is the same thing that we are doing here. This tuple here that you are seeing here is what we have done here. This tuple letter comma number is what we have done here. And this append is what we have done using this particular square bracket. Square bracket open and close. This is exactly what we're doing. So anything that is inside here is going to be a tuple that is being housed inside a list. So you can see here, I started with a square bracket, letter, comma, number, showing that it should be a tuple representation. So anything that comes inside, any value that we get for letter in letters, for number in numbers, is going to come in this particular format. So you can see for letter in letters, which already have A and B, and it's going to come out the number of times in which number appears to have on that particular list. So that by the time you call out the result underscore com, is going to give us what? The same thing that we got for what? For the classical way of doing it. I don't know if there are any questions. If there are any confusions, please ask questions now. Comprehension is something that is actually wonderful when it comes to programming, though sometimes most people see it as a way of maybe making things more complex, but it's quite easy enough if you look at it very well. Please, if you have any questions, please ask your questions. It's very important that you ask your questions. Please, if you do not understand, please let me know, or should I proceed? Mr. Funso, please, should I proceed? Dr. Kwemi, Ms. Emedion, Mr. Sunday, Mr. Mark, or Mr. Fonobon, should I proceed? Or there are questions? Please, if you have any questions, please ask. It's very important that you ask your questions. I hope I'm safe. Everybody is just quiet. Hello, can anyone hear me?
You can proceed.
You can proceed. You can proceed, sir.
Okay, because I was like, oh, Paul is well. Okay, but at least you're understanding what is going on. That's the most important thing. Oh. Okay. All right, so you can look at it. Let's move to the next example. And this particular example, it might be more complex when it comes to see the result. So the next thing is we want to create a dictionary for numbers from 1 to 10. Okay, a dictionary of numbers from 1 to 10. The number itself will be the key, and a list of all the numbers less than or equal to that number will be the value. So if you have something like this, so this is a dictionary. Remember, a dictionary comes in a curly bracket, and they're trying to say that the key should be the number, and the value of that number should be what? Should be less than or equal to that number. So if you have something like 1 here, the value should come in as 1. If you have 2, the value should be 1 and 2. If you have 3, it should be 1, 2, 3. Just like that, if you have 10, it should be 1 to 10, okay? So how do we make this possible? So we're going to look at it in a classical way first. So now this thing is going to come out again for I in this and that. So let's see. We want it to be 1 to 10. So, and we want it to be in a dictionary. We could have decided to use something different here. We could have decided to just use a curly bracket here, but I'm using DICT. You can also decide to just use a curly bracket. That's all. So now we start the forming of this particular example to create a dictionary of numbers from 1 to 10, and each of the iteration should have the number less than and equals to that particular number as the value compared to the key. So for I in range, remember we're looking at 1 to 10. So we start with 1, 11. So by the time you get this, remember you have already defined a dictionary. So for I in range, this is for the first value of what? Of I, which is going to be what? Which is going to be in what? The key itself. So now the value is now what we are now going for in this particular J. So anytime we have for I in range 1, 11, it means that particular one, we are using it as the key. but that key is quite dependent on J. Is quite dependent on J. Please pay attention to the number 7. Number 7 is very important. So for J in range 1, comma, I plus 1. Okay, so now if you look at this, now let's go to this code, this particular example that they gave us. So if you look at this particular loop right now, for J in range 1, comma, I, if you look at the I that is going, this particular one that is going to come out, the last of it, for example, if for example, you wanted it to be 9, the last of it will come out as 9. Sorry, the last of it will come out as, let's say we wanted to use 9. The last of it, the last number here is going to be what? Is going to be what? 9. If it's 9, if 9 comes out here as I, it is not going to give us what we have here as 9. At the end, the number will not be 9. It's going to be 8, because range always takes the last word. It doesn't put in the last number. So if this place is 9, if this place is 9, it means automatically it's going to return 8. So for us to make sure that this place becomes completely 9, we now add plus 1 to that particular value of I, which is going to make it what? For example, if this particular one wanted it to be to reach this particular 1, 2, 3, 4, 5, 6, 7, 8, 9, we need to make sure that this particular place, as it's coming out in the loop, if you put I here, it is going to be what? It is going to be what? 9, which is going to be 8 if you want to look at it in terms of range. But we added plus 1 to it to make it 10, so that when the range comes out, it's going to give us the value of 9. So that's what happens here. So for J in range 1, comma what? I plus 1. If we leave it here, maybe at some point, or maybe once we do with this example, I can remove that one. You can see how it's going to be like. Now, the next condition, we're just trying to set traps for it. So in case this one happens, this is how it's going to happen. So if already not in dates, that means if it's already is not inside this dictionary, if not I in smaller, that means if I is not in this particular smaller, which is what? 1 to 10. If it's not there, we want to say that what they call it, small as I, that means the value of I, which is the key, is going to be equals to what? J, which is going to be what? The value itself. So it means that this particular one here, if 1 here, 1 must also be the what? The same with what? 1 must also have 1 inside what? This particular word as key. And also the key here must also have the same distance as what? Value. Okay? So anything that we have for I must also be represented in what? In that particular value as what? J itself. I don't know if someone is getting what I'm trying to. Oh God, I wish. Is it getting complex, or I don't know if I'm confusing you the more?
I don't understand the new line, this particular area you are talking about now.
Okay.
This condition, so, if not I is smaller.
Okay.
I don't get.
All right. Okay, we are going to explain. Let's first of all, let me comment. Let me comment it out. I'm going to comment it out so that we'll see the usefulness of it when the code runs. Okay, so let's run this now. Let's run this now and see. This is before I run. This is the main outcome of this. This is the main outcome of this particular one. So let's run this now. Where is this? Okay, let me just try to. So you can see there is an error here. Trying to decide where it's coming from. So on line 15. We expected an indent block, Y. Okay, so indentation block, expected an indentation block. Why is there an indentation block here? Let me, let's, okay. Hello, Medium?
Yes, so I said it.
Hey, Medium, please tell us something. You have seen or you have encountered something?
No, I'm talking about the indentation error. The colon is still there on the for loop, so it's expecting something under that block of code, but there is nothing there.
Okay, you mean here, right?
Yes.
That's exactly. So I made a mistake by saying I need to comment this out. So okay, first of all, let's just say for I in range, okay, this is what we do. This is okay. So let's leave this. Let's leave one of it. And also we cannot leave any of them. Let me just leave it and run it at some point. Let's see what will happen. I will explain better. So it's running for us now, but I'm just trying to find a way to make sure I explain this perfectly for you guys now. So let's see. Trying to make sure you get it. Mr. Sunday said he did not get it, but I don't know if any other person has issues to not getting it, so that we can actually know how many persons. Or if you understand it, is there any way you can make it better for someone to understand? Since my explanation, I'm just trying to make sure that. So let me just go straight. Let me see how we can actually explain it to Mr. Sunday if he's the only one, because I know he's not the only one. So what he's trying to say that for J in range this and I plus 1, this particular one, Mr. Sunday, please, do you get it up to that level?
Yes.
Okay, good. So if already not in list, this comment is trying to tell you that if already it is not in this dictionary, that means anything that we do for J, if it's not inside this dictionary, this is what I want you to do. So if not I in smallers, what should you do to I? It means you should do what? You should have that particular I that is 1 to 10 should have a what? Should be a key. And that key should take a particular value, which is in what? J, which is J. I don't know if you get what I'm trying to say. It means that as you are going through this loop and your value, let's say when you're trying to get your loop here, your particular dictionary here, 1 to 10 was not, maybe let's say 6 was not in that particular loop, was not in that particular dictionary. This is what I want you to do. I want you to make sure that that value for I, that particular value, which is what inside that is an empty dictionary, which I've already done here, should what have a value which is also what? J. I don't know if you get it. Anybody that understands it, can anyone raise up their hands and explain it? Dr. Kwemi, do you understand what is going on? Dr. Solomon, do you understand what is going on? And Mr. Sunday, if you are speaking, I can't hear you. It seems the network.
I'm not actually speaking. I think my just.
Okay. Anybody that wants to explain it to the way they understand it?
Hear me?
Yes, I can hear you, Dr. Kwemi.
I said I still have some questions. For you to finish.
You did what?
I have some questions. For you to finish them.
Okay, all right. Okay, no problems as well. So let's just see. So else, what are we going to do? Else, we can also say small as I dot append J. all these things I'm just trying to do is just trying to like say, okay, this is what we should do if this is not going on in the particular kind of loop. If this particular thing is not working for us, this is like a catch kind of something. Like, okay, small as is equals to j, and if it's inside here, that means if this particular small as is already found, if this particular I is already found, okay, if it has already been found, and that means this particular one does not, this condition is not met, it means it should do this to it. So that means if small as I equals to what? J, if it's not, that condition is not met, that means else, what should we do? We should append the value of what? The value of I into what? The value, which is, sorry, the key, which is I here, should be appended to the what? The value of what? J. So all the J's here are the values, while all the I's are the what? The keys. So this is just like anything that we do inside these conditions. For I in range this, you have gotten it out. So for J in range this plus I plus 1, I plus 1, it means that each of these particular values that you have gotten for J is going to come out, yes, but the range of it will not be able to allow it, because range always does not have the last one that comes out of it. So it's going to come out as what? The last value of this particular for loop of 5 will be 10. So anytime we want to get the value of J, we need to do what? Add plus 1 to it to make sure that all of it is what? Completed up to the last value of the last number of the what? The key. That's why we are doing this. Remember, the condition was trying to tell us the number itself will be the key, and a list of all the numbers less than or equal to that number will be the value. So that's what we did here. So if not indeed, this condition is something that is actually giving us headache right now. So if not I in smallest, I don't know if you are. If not I in smallest, it's very explanatory. If not I in smaller, that means if I is not in smaller, we have already gotten the I itself. But if it's not inside the smallest that is in this dictionary, this is what I want you to do. Wherever we found the value that we got in this particular loop for J, please, I want it to be the value of this I that we should be what? We should put it inside what? Smallest. Smallest is an empty dictionary in which we have defined already. Is an empty dictionary. So if anything that we are trying to look is not found inside this dictionary, and that particular value is I, we want it to what? To be the key, and the J should be the value. But if this already is found, we want to say, okay, smallest, we are calling out the name of the dictionary, which is smallest, and the value which we have is I, which you have already looked, dot append J. That means anything that we do now, we're going to do what? We're going to add the value, which is going to be dot append to what? J, which the key, sorry, I is the key, then J is going to be the value. Okay, Dr. Kwebi, please answer your questions as well.
You've answered them.
I've answered them.
Yes. Yes.
Okay. Okay. I'm seeing someone's work in the. Okay. I'm seeing someone's work in the chat. Let me see. Let me try to. Okay. What did you do to your code? I'm seeing an empty list somewhere. Embedion, I'm seeing an empty list somewhere. But it's still giving you your answer. It's more of like maybe it's the way your own pipe. This particular one is what they call it. Mine is Jupyter Notebook or Colab itself, but it's coming out. I'm seeing things here. It's exactly as we wanted. Let me see your. It's working here for you now. Just okay. Wanted it to be in that kind of range. All right, thank you very much. I think someone has tried out. You can check our code as well. And if you do not understand, let's always find a way maybe to try and get it done again and again. We'll find a way to explain it more and more. Maybe I can go back and find out a simpler way of making it understood enough for you to get it. It's very, very important that you understand some concepts and make sure you get the best out of it. Okay, so you can, okay, Mr. Sunday, please ask your question.
Okay, thank you. Please, can you go back to the code?
Okay.
So I would just want to know, I've seen where you added the value now, like if it's not already there, so it should create one and be added to the empty dictionary. Or
Yes.
It's already there.
If it's already there now, append the values of it.
You should just add the value. So I think I understand now. But I'm just looking at, why is it that the value is inside like a list? That J, why is it the bracket?
Yes, exactly. Thank you very much for that question. It's actually true. Why is it in a bracket? Because we are putting it in a list. Thank you very much. It's very important. That J is coming inside as a list. We could have decided to put it, if you have left it like this, it could have not been inside a list. So that's the reason why it is inside a list. Remember that the append works for list too. So append is a function, is a method used for list. So it's going to go inside a list as well. Thank you very much for that observation too. I forgot to tell you that the square brackets here in the file, this particular square bracket is in defined that we want to, the values of J is coming in form of a list. Thank you. So that's why it is done that way, Mr. Sunday. Okay, Dr. Payemi, your questions.
Okay. Let me see your screen again.
Okay.
So, the questions I have.
I thought you said I answered them.
Yes, you answered them. I spotted another one just now.
Okay.
I think the condition in line 10, I think it was made, right? I'm asking.
Yes,
I think it was.
Yes, the condition. Yes, continue. Yeah, the condition. The condition.
Line 12.
The code in line 12. There's a code. The code in line 12
was not.
The code in line 12 and 13. Yes, it's more of like an internal kind of something here. When it comes to dictionary things like this, if we are just trying to, like I told you before I started, like it's just to find a way to catch it up, or we don't know what might be going on inside the dictionary here at some point when it's looping. So I was just trying to say, okay, let me just use what they call it. Let me just use a catch-all kind of way of saying, okay, if this particular one is not this one should be what we should do.
Like a fail-safe.
Yeah, it's like what I'm trying to say is that I'm just like trying to bring a condition.
Is this like that?
Yeah, this is what I'm trying to say. Okay, let me bring a condition. That particular condition was just like if not. So if not I in smallest, it means that whatever I'm doing right now, I need to bring in the else statement as well, because I can't just say okay else. I can't just remove the if and say okay, this is what I want. I just brought a condition here, and this condition was just to, like, in my normal kind of, let's say as a programmer, let me just say, I was just thinking of it as a try catch kind of. I don't know, you guys are not going to error handling. I was just trying to see it as a try except kind of block, kind of something. So that if this particular thing is not inside this dictionary, this is what I want you to do. So you could have used another condition entirely. You could have decided to say, okay, if this one is greater than, or maybe if I is less than J, this is what I want you to do. But this is my own kind of, you could have also used another way of doing it. I don't know if you understand why I did that.
Yes, I understand. That's why I was saying it's like a fail safe in case.
Okay, I mean, I don't know what it's fail safe. I don't know what it's,
Yeah.
Okay.
I understand, but the condition in line 10 was met. So line 12 and 13 did not actually work for the result for this output.
Okay.
That's what I wanted to.
Okay.
Thank you.
All right. Thank you. All right. Any other observations? Okay. So you can actually bring out your own conditions as far as it is met, and you go through this smaller I equals to J and else this and that. You could have used, I think Emedion tried something in our own. Emedion, what did you use in yours? I think she tried something in her own. She did not bring in all these my conditions at all. Okay, so you can see what she did in her own this thing, and it worked for her at some point. And let's just go to the next thing. Let's see what we have for let's look at the comprehension part of this particular issue. And you can see it here is very straightforward. It's very, very straightforward for us. You can see, first of all, we are already saying that the smallest underscore com equals to, remember, we want it to be in a dictionary first, a dictionary of numbers of multiples of numbers less than or equals to the value of the key. So you can see here, I already is standing on his own. Like I is to like this particular dictionary confirmation and say, okay, anything that is coming in as value will be inside a list. You can see I started with a square bracket and I said, okay, and this particular value is going to take the form of J. So J, for J in range, 1, comma what, I plus 1. It means that the value that is coming for this key I is simply going to be what? Is simply going to be J. And this J must be in a range of numbers from 1 to what? I itself. But that I, remember, when it comes to range, if this particular I was, let's say this particular I was 8, this particular I is, let's say, is 8, for example, this place is going to come out as the last value here is going to be 8 as well. But because of range, we added +1 to it so that whenever it's going through the particular looping and it comes out as a value, this place is going to turn to what? This 8 plus 1 is now going to be 9, so that it will what? Take the place of what? That J will represent what? That J will represent that the last value will be what? 8. Okay? So that's why we did this +1. Remember for that. Now we now said, okay, we are through with J. Now this is the one we are doing for just I. So for I in range 1, 11, this is the values for I. It comes out perfectly just as we did. This particular one, we did not involve this condition. This condition here, I have not put it inside this condition that you have seen here for if not I in smallest and else smallest dot disappend. I have not done it in this nested comprehension. It's not here. I just went straight to the point. We can look at it very well. There was no condition, say this and that. I will just bring this one. I was just trying to come up with something here. Okay. So you can see I comes out on his own, colon as a normal, like as it is in dictionary. J, you now started looping for J. This particular one is for J. So any value that we have inside this square bracket is for J. And now this one that you're seeing, this for I in range 1, 11, it's just for the values of I. So it's going to come out as 1 to 10, and this one is going to come out as 1 to also the value of I itself. We can see how one the time we call the smaller underscore com, this one comes out exactly as we wanted. So this one is more simpler and it's more explanatory in just 2 lines of code. I don't know if you have any questions at this point to ask. Nested comprehension. Is there any questions? Okay, Dr. Kwe, miss questions, please.
Yes.
Thank you.
I would like to see. Okay. So is it possible for us to start this line 3 with code in line 4 for high in range 1 to 11 first before we now do the. I don't know if you get the question now. I'm saying, is it possible for us to start after smallest that is equals to then the dictionary curly bracket? Then we'll say for I in range 1 to 11 before we now continue. Is it possible? Just want to know.
Okay.
For us to do for
let's,
I.
Let's.
I'm just asking.
Let's try it out. Let's try it out. It's definitely it's supposed to be very possible, but let's see. Let's make it happen. Let's see what you can do. So let's paste it here, and let's put this on enter here, and let's run this. So what is it trying to tell us? So line 3. So you can see. Let me. I think the mistake. So we can see when I told you it was, first of all, whenever you are trying to, I think Mr. Mfonabo asked this question in the last class. He said something about can we just do this thing before we call out the this thing. First of all, that's why it's called list comprehension. First of all, you must give an arbitrary variable first outside, even though it's 1 or 2. You have to keep it 1 outside first before you get things done at some point. I don't know if you understand what I'm trying to say. That I is using as a reference to when it comes to this particular kind of for loop here. So it's still saying the same thing. So let me Control Z. What have I done? Okay. So I think this is how it was before. Yes, it is how it was before. So first of all, whenever you're trying to look at list comprehension itself, a value must be given first. For example, if you can see all that I've done first, you can see here I started with letter, comma, number, when I did not even know what letter, comma, number would be. Dr. Kwame, are you following what you're doing?
Yes, I'm trying my best to follow.
Okay. So you can see this letter, comma, number was not given at some point. And it was when we now look through it that we now had to say, okay, we are referencing it in this particular letter, comma, number. Let's go back to another one that we did. So you can see here, the same thing here happening in this particular comprehension. So I for L in Pepe. So L, is it I or L? L came in first. It did not give it a value first. So it was when you now gave it it was after you now said, okay, for L in Pepe, that's when let's go back to another one. Let's see another comprehension. You can see here, another thing here comes in here. Lang colon year. We did not know the value of lang colon year before we went into the looping process. So it was when we now looked into this languages stroke years, comma years, that's when we now found out the value of lang, comma year, and we got whatever we got it. This how it's supposed to look like. It came out like this for us. So I don't know if you get it now, if you understand what is going on. The same thing with J here. J did not have any value here until we now went into the for loop, the for J in range. That's when it now gave us the value of it. So I don't know if you get it now. Okay. Dr. Sunday. Okay, Mr. Sunday, for sure. I'm very sure he's going to the doctor level as well. Dr. Sunday. Yes, Mr. Sunday.
Okay, so for this, so you are telling us like comprehension now.
Yes.
The key will come, then followed by the value. Because I was just thinking like possible for us to that I, then we now put colon. Yeah. We now say for I in range 1, 11. Is it possible that it come before the square bracket? J for J in range 1, is it possible for I in range 1, 11 to come before the square bracket?
Okay. Let's try it out. Is this what you wanted? Is this how you wanted? You were thinking about it?
Yes.
Okay, so it did not work out for us at some point because I think it's the same thing. We're trying to look at the format of what this thing should look like, what what they call it, outcome should look like first before you now say, okay, once I've gotten this particular value here, let me go and range for I in range 1,11. So we have tried different ways of making things, and this is how it came out for us. Okay. So I always believe it's something that first of all, you must put it in the way you want it, the format in which you want it. So the last one always tends to come out. The first one always tends to, like, you have to try to make sure that the for loop comes in the last of it. But nevertheless, it's in code, a lot of things could work for you. At some point, there are sometimes you build your code, and even though you don't even like, you see that it is working, you just have to stop it there. So there are some ways you can manipulate this thing for you at some point, and it works for you. And it may not really be looking like this, but as far as it works for you and you understand why it's working for you, please leave it there. But you can see here what happens here. We have tried different ways. Dr. Femi has said something. We tried. You have said something as well. We have also tried. And this is the only way that is working for us at some point. So that's where we'll stop for now. And let's continue. Let's look at how, and maybe there's another question somewhere. Okay, there are no questions. I really wanted to finish comprehension today, and my battery is actually low, but nevertheless, there's always a way out. To drag that gen out now is voila. Let's find the odd numbers from 1 to 20. Let's find the odd numbers from 1 to 20. I believe this is a classic. This one, guys, you guys can do this one. Looking at this code, just define an empty list. Odds equals to this. So for I in range, remember we're looking at 1 to 20. So we do 1, 21. If I, modulus 2 equals 1, remember this is going to be an odd number kind of. If it was 0, it could have been for even. So whenever that condition is met, you want that particular option, option that is met, that condition that is met to be append to what? To be added to an empty list, which is odd. So you can see here, by the time you now say odds.append, what are we appending? The value of I. And by the time we call that odds, if we print the odds out, it's going to give us 1, 3, 5 till we get to 19, which are all odd number. Okay. So you can see here, if we look at the comprehension part of it, you can see here, we go into the comprehension part, for I in range this, if I modulo 2 equals 1, this is what you want us to do. So it's a very simple case here. Odds_com. Remember, we want to put it in a list. Okay? We want to put it in a list. Remember, this odds here was a list. So we now said odds_com is in a list, all of them inside a list. And we started with I. Remember, this is the condition for I. And I said for I in range is, okay, whenever you have that I in that range, is in this particular range, if this particular condition is met, is it equals 1? That means it is an odd number. It should enter inside this particular list. I don't know if you understand this concept very well. Anybody that has questions? Hey, Mr. Mark, I have not said anything today. Mr. Mfonobong has not said anything. Mr. Funso, I hope all is well.
Yes, all is well.
Yeah, we just mentioned my end.
Assimilate. It looks like mystery.
Oh, God of mercy, how are we going to do this? but okay. But look at it very well. Like I just bring out the programming part of you also, because we need it now. It's more of like we are comparing two ways of doing things. You can decide not to use this comprehension at all. That one is no problem. You can decide, say, I'm not going to use this at all. don't want to use it. Let me just use the normal classical way. That seems that one I can understand it more, but this one is simply enough. You can just say for this I, you bring out the I itself first, and you now start working on it. Now start figuring out yourself as well. And this particular one is more of like it could be a complex one. Let's see. We want to create a dictionary for numbers from 2 to 20. The number itself will be the key, and the value will be the list. Okay, and the value will also be what? A list. This list is going to be positive factors of that particular number. For example, we have let's say, let me say something like when it comes to positive factors, we mean that if we don't need negative numbers. That means apart from one, we're looking at from, remember it says from 2 to 20. So what are the factors of 2? We have just 2 itself that we can use. 3 has 3, 1 and 3, but we need 2 from 2 to 20. So you can see 4 has 2 and 4. 5 has 5, because it could have been 1, 5 as well, but we need 2. 6 has 2, 3, and 6. 7 like that till we get to 20. So that's what we're going to be doing. And please, we're also going to be using that concept. Please confirm you can hear me. My headset is off. Please confirm you can hear me. My headset is off.
Yes.
Okay, thank you. All right. So if you look at this now, remember we want it to be a dictionary. So we are starting with a factor with an empty dictionary here. And if you look at the same range again, so for I in range 2, 21, remember it's 2 to 20. We now said for J in range what? 2, what? I plus 1, the same thing that we did in the last class. Now to check if it's a factor. So anything that we have for I, if I modulo J equals 0, it means it is what? A factor, right? If I, that means the value of I that we have is what? Is divisible by the value J that we have gotten as well, which are going to be this one's like just like the other one, but it's going to come out and say, okay, if each of these value that we are having, which is J, is whenever you divide it, whenever you go through a modulo division, is not going to give us any remainder. It means that is a factor. Okay, it means that is a factor. So it means it's going to be what? Added to that particular dictionary. I did the same thing here again. I brought out this condition again. If not I in factors, okay? Remember what I did here? If not I in what? In factors, do this. So immediately this condition is met. Anything that we get here, what did Dr. Payemi say? Say something. So by the time you now say, okay, now let's use this and say, okay, if it's not inside this particular dictionary, if this condition is met and yet it's not still inside this particular dictionary, put these factors I equals to what? A J, and should be in a list. Else do the same thing here, dot append. And by the time we bring it out, the factors will come out just like this. But what I want you to do right now is use this same condition, this particular method I've used now, use it for what they call it, the comprehension part of it, exactly how we did. Remember this, how we did for this particular one, for the numbers of this particular one. You can see what we did here, exactly the same thing. The only thing here that is changing is the condition. We have put a condition here under this particular J side, and this was the comprehension of it. So now let's use this same way of making things work for us. You guys have the notes already, so there's no need of me hiding things, but just come up with something. What do you think it should be? Now that the condition is here and we now add it, how can we make it in a comprehension kind of way? You want to, is someone trying? If you are trying, just raise up your hand. If you are trying something out, raise up your hand so that we know whether to continue. Okay, and please just try, come up with something. Come up with something, bring out the best in you. Let's see what you can come up with. Just come up with something. Try out something, Is anybody trying something out?
Yes, I'm actually trying.
Okay, just let's see what you can come up with. Please try something. You can also drop it in the chat box, in the chat room, on the WhatsApp group.
Sorry, what are we asked to do, sir? Mr. Median.
Okay, we are trying to, we have done the classical way of this looping, but we want to find it in a comprehension way of this particular loop.
Okay.
Please, people should type, people should bring out suggestions how we can make it work. It's very important that we do some hands-on. I know coding is something else. It's looking strange at some point, but for the fact that you are here, you are strong enough to understand this. It's very, the next one that is coming is going to be a project. So don't worry about it. We're going to do it step by step. This one, I will not be putting out codes for you to just be looking at it. We'll just be going through one. Please, at that particular stage, maybe tomorrow, as I'm coding, you code. Because if you miss that particular one, if you miss anything, you have missed it. If you miss it, you have missed it. Like if I'm trying to do a particular thing and you do not do the same thing, you are going to miss a whole lot of things. So it's better tomorrow, as you are joining in, come in prepared to code as long. Because if you say you want to wait for me and say after the class you go through it, it might be an issue. It might be a problem because this particular case is more of like we're using a GUI, that's a graphical user interface. And you're going to see the snake game as you're building it and testing it as you're also building it. So, and also you need your Anaconda installed on your system. You need your Anaconda installed and get ready for it. Anaconda should have your Jupyter lab. We'll be using the Jupyter lab as well. Or for those of you that have PyCharm, you can also use it, but I'm not really advising because you want to test each of the cell in each of the steps as we are building. So if you do not have it, try and download Anaconda. Just Google search Anaconda, download the one that is not paid. It's going to help you enough. And I think it's how many megabytes, but it has space, sure. Okay, I think Dr. Kwemi, I've not seen your stuff coming, or maybe we'll just have to continue. Go ahead, or is it still coming? Okay, I can't hear you. Okay, let's just maybe once you're done, don't worry about it. Once you're done, just post it. Let's see if you're almost getting it at some point. So if you look at it's just like this. So what it will do, remember, is going to be in a dictionary, and we'll start with the I itself. And by the time you now said, okay, Remember that the condition for I, the looping for I will come last, as we did in the former one. The looping for I will come last, but the condition will come in immediately after the for loop for J, and is going to still be inside what the list is. Remember the square bracket here. The value that we are going to get is going to still be inside the list of J. So everything must be inside what the list of what J. So for J itself comes out for J in range this. If I percentage, that's the modulo J equals 0, it means it's supposed to be inside this particular list. So for I in range 2,21, bring it out, it gives you the same thing to do. So that's how it's been done. You can also do the one for even numbers. So what I'll do right now is try the one for even numbers. Let's see what you can come up with. It's almost the same thing. The only thing is you just change this particular one to 0. Remember, if it's odd number, it's going to give us 1. There's going to be a 1 remainder. If it's even, it's going to be 0. The same thing. Battery will soon be off. So we just find a way to make sure this is done. It's very simple. The same way you did for odd number, you can also do it for even number. You can see the exact same thing we did, and it worked for us perfectly well. Okay, so that will be where we stop for comprehension. Please go through the notes again, go through again and again. At some point, please, it's at this stage of your learning, if you do not understand a concept, you can request a video call with me. You can say, okay, I can send you, whenever I see that you are still having issues, I can send you a meeting link, and we'll go to you, share your screen, and let me see the errors which you're having, so that we can sort it out. I can sort it out with you. It's, please, you have that right. As far as I'm free and I'll just tell, okay, I'll send a meeting link, you can share your screen, and let's see what error that you have. It's very important that you try to, this is your debugging stage of your learning. You get to, you will see a lot of errors. Please make sure you meet up with me or Google and check it out, and make sure you fix your errors. This particular stage, you might have a lot of errors. It's very prone to happen. So it's good for you to make sure that you know how to debug them. If you see, try, it doesn't work for you, please request a call with me. I will put myself across to you and send you a link. You share your screen. Let's fix it up at some point. Okay, let's see what you have. Okay, fantastic. Well done. Well done. This is nice. This is really nice. Thank you, Dr. Kwemi, for trying. This is really awesome. Thank you very much. Thank you very much. This is really nice. Thank you. And yes, okay, for this in this, okay, equals 0. Even add the condition immediately. That's nice. This is correct now. This is really nice. This is nice. Thank you very much for trying out. Thank you very much, and we are through officially. We are through with comprehension. The same thing we did for odd numbers, we can also do the same thing for even numbers. So at this particular point, if there are no questions, please ask questions. If there are no questions, please let me know. Please don't always feel, another thing I would try to tell you, that don't always feel bad when you search Google for answers. No, as far as you just understand what you're looking for. Googling is a very essential skill. Try to learn it, not just blindfold Googling. There was a time my boss, I can tell a practical case, he called me and was like, please, have you been able to sort a particular problem? I told him yes. Okay, I never knew he tried days and days, he could not solve it. So he now gave it to me to try to see what I can do. So when it was not up to how many, so just few minutes, I told him, yes, I've been able to solve it. I sent the data to him, and he was like, you have solved it? I said, yes, sir. And how did you do it? So it was when I knew I had Googled that stuff to find the answer. Like, I remember what with my knowledge of programming, I Googled it out. I said, this is a particular case I've handled before. What can I do to make it better? So when I Googled it and I saw the kind of something relating to my answer, and I knew what he was looking for, I added it to my code and I gave it out to him. So if I did not understand what the code was doing, when he asked me to explain it to him, I wouldn't have been able to explain it to him. So it's not just for you to Google, it's for you to know exactly what you are Googling. Okay? You don't need to cram everything. You just know how to problem solve, know how to know what it's all about, know the logic behind it. Just know the logic behind that particular line of code. Now we now see that if you do two for loops inside one, you know that the first one is there, the other one is just trying to like loop with the other one. Maybe for example, you are trying to create something like what you have done tonight, you're trying to create a key, and the other one is like a value. You can see what is doing, those nested for loops that is coming in. So you just have that mental, okay, that's the logic behind it all the time. If that's what he has been doing it all the time, okay, now let me use that and apply it into my own way of programming. So that will be all for tonight. Thank you very much for joining in, and have a fantastic evening. I just prayed now that I recorded this session in another meeting link, the previous meeting link, if it's to still show as recorded. I just hope it does, because we did a whole lot of debugging and trying to explain some concepts. It's always very important that we have this kind of videos so that people will see that we are not perfect. We'll just try to make sure that everybody is taking along, everybody knows exactly what they are doing. So thank you very much, and bye for now. All right. Yes, so
hope it is recorded.
yeah, it was recorded, but I don't know. I know it was in the former meeting link. So let's see.